What if the universe lets you decide after the fact how the past behaved? Not by time travel, not by memory, by choice. The quantum eraser experiment suggests that decisions made in the present can change what the past appears to have been, and this has been tested repeatedly. This experiment is real. It uses the same physics as the double-slit experiment, but it adds one disturbing twist. By the end of this video, you'll understand how future measurements can determine whether particles in the past behaved like waves or particles, and why this does not break physics but completely breaks intuition. In the double-slit experiment, particles like photons behave like waves when not observed. They create interference patterns. But the moment we measure which path they take, that pattern disappears. Observation changes reality. That's already strange. But the quantum eraser goes further, because now we ask a new question. What if we measure the particle later? In the quantum eraser experiment, particles are created in pairs. These pairs are entangled. That means their properties are linked even when separated. One particle travels toward the slits, the other is sent elsewhere. Crucially, information about the first particle's path is carried by the second. What which path information really means. Interference disappears when which path information exists. Not when someone looks, not when it's recorded, but when the information could be known. That's the key. So the quantum eraser asks, what happens if we erase that information after the particle has already hit the screen? The delayed choice quantum eraser. In the delayed choice version, the first particle hits the detector screen. Only later, a decision is made about the second particle. That decision determines whether which path information is preserved or erased. And when the data is compared, something impossible appears. The interference pattern depends on a choice made after the particle arrived. What the results show. If which path information is erased later, the earlier particle behaves like a wave. If it is preserved, the earlier particle behaves like a particle. It's as if the universe waits to see what information will exist before finalizing what already happened. Does this actually change the past? No signals travel backwards in time. No information is sent to the past. Causality is preserved. What changes is how events are correlated once all information is available. Reality is not finalized until the full experimental context is complete. Quantum mechanics suggests something radical. Events don't have fixed properties in isolation. They gain definition only within a complete system of interactions. The past is not rewritten, but it may not be fully defined until the future arrives. The universe doesn't run like a recorded movie. It behaves more like a calculation that finishes only when all inputs are known. Reality is not undone, but it may be delayed. If this unsettled you, leave a comment. Do you think reality is fixed or contextual? Like the video if this changed how you think about time. Subscribe because quantum physics is stranger than fiction.